of trigonometric functions. So now we are going to discuss the derivative of trigonometric functions. In this, the first function is the most basic function, y is equal to sin x. So the differentiation of sin x comes out to be cos x. So this one you need to remember, that the differentiation of sin x is equal to cos x. Now you can also derive this result by just doing this one, that y dash is equal to sin of x plus h minus sin x upon h. Now if you open this out, sin a plus b identity, you will get the result, and this will come out to be cos x when you put the limit of h tending to 0. So this will be a question of general limits. This you can solve, but just remember the result, that the differentiation of sin x comes out to be cos x. And the second result is the differentiation of cos x dy by dx, in case y is equal to cos x, dy by dx comes out to be minus sin x, right? So this is the second basic function. The third one is dy by dx of tan x. Now d upon dx of tan x can be written as d upon dx of sin x upon cos x. Agreed? Now we can see that this tan x function is the quotient, will follow the quotient rule, because in this case we are getting a ratio of two given functions. Now I know the derivative of both these functions. The derivative of sin x is cos x and the derivative of cos x is minus sin x. So I will try to differentiate this one. So by applying u upon v rule, the differentiation of u upon v is equal to, in the denominator we get v square, in the numerator v u dash minus u times v dash. So in the denominator I will get cos square x, in the numerator I will get cos x into differentiation of sin x, which is cos x, minus the first function as it is, and the differentiation of denominator, which will be minus sin x. Now the differentiation of cos x is minus sin x. That's why I wrote like this. So this is cos square x plus sin square x divided by cos square x. This is becoming 1 upon cos square x is equal to sec square x. So the differentiation of tan x is nothing but sec square x. And that's how we derive this. Similarly, the next one is d upon dx of sec x. Now sec x can be written as, this can be written as d upon dx of 1 upon cos x. Now just do it by the quotient rule only. This will come out to be sec x tan x. Similarly, d upon dx of cot x. Now cot x can be written as the quotient of the ratio of cos x and sin x. So we will apply the quotient rule to get this result, and this comes out to be minus cosec square x. And last one is d upon dx of cosec x. This is equal to minus cosec x cot x. So the derivations are not important, but these all the results. All these results are very important. So I will write it down here. I will summarize what we have learned. The first one was, now y is equal to, in the first case, y is equal to sin x. So if y is equal to sin x, y dash comes out to be cos x. And if y is equal to cos x, y dash is equal to minus sin x. So the first two are pretty easy to remember, that if we have sin x function, the differentiation will be cos x, and in the case of cos x, I will get minus sin x, right? All the trigonometric ratios are getting reversed, sin x converted into cos x and cos x into sin x, but in the case of cos x, I am getting a minus sign in addition. And the third one is, if y is equal to tan x, in that case, y dash is equal to sec square x. This can be easily proved by quotient rule. Similarly, fourth is y is equal to cot x. Then y dash is equal to minus cosec square x. Now see, in this case also tan x differentiation is sec square x and cot x is minus cosec square x. Like in this case, the differentiation of cos x was coming out to be minus sin x. In this case, the differentiation of cot x is minus cosec square x. So this is a very easy way to remember. If you remember this one and this one, you will easily remember the other ones, right? So the differentiation, the next is differentiation of sec x. So the y dash is sec x tan x, and the last is differentiation of cosec x, which is minus cosec x